Today I'm speaking with Jim Holmes. Jim, how you doing?
I'm doing well, Dave. Thanks.
Great. Jim, what do you do?
I am currently the QA lead at Intelligent Systems, so I'm responsible for kind of the quality of products that we're delivering, and I work with a team of 2 folks who work for me. I've got some other resources available, and this just kind of dovetails. It's a progression of things I've been passionate about for a long time in my career: testing, good development practices, and getting good software out to customers.
Okay. Well, if you're in charge of quality, I imagine there's a lot of testing involved in that.
Yeah.
I've talked to you many times about the importance of unit testing. I know that's something that you've got a lot of passion for. Can you define for us what is a unit test?
Sure. So a number of people will give you different definitions, but I see a couple different levels of testing. So let me start with things that aren't necessarily unit testing, but kind of working backwards into it. So there's functional or acceptance testing, where really that's something that I have an active role in now, which is, does this feature that we built work as expected? And so it's kind of on the broad scope, right? So when I fill out the form and I hit submit, do all the right things happen in the system? So it's kind of a slice of a feature. And that might be UI testing or something along that lines. So then if we take a step closer to the metal, there's integration testing. And that is, say, testing between a couple different components in your system. So maybe from your persistence layer all the way down through the database and back, right? So I've got a method that I might call with some parameters that does some stuff and goes out and saves something to the database. So my integration testing would kind of test that interaction across those layers.
Okay.
So now, at the smallest level of granularity is unit testing. And unit testing doesn't cross any boundaries of things. So it's like one specific method. If I have a method that, say, is around computing payroll wages, a unit test would say, if I give it these number of hours and this rate, do I get back this expected value?
Okay.
And so it's just within this one small unit of code, and it doesn't interact with other components or other services.
Okay. And why is that important? Why do we care about unit tests?
So you can talk to a broader set of methodologies and approaches like test-driven development or behavioral-driven development, but the idea of being able to test something at small units is, first off, to guarantee that that little unit that you're concerned about works as expected.
Okay.
So I might have a payroll test that has, say, maybe a couple if statements in there or some logic in there, and I need to feed in different values to make sure that that thing works as expected. And moreover, as I start to build up a suite of unit tests, as I make changes to the rest of the system, I can ensure that I'm not breaking something, either a regression or when I have to change different parts of the system through refactoring or, say, updating or maintaining or fixing other bugs. I'm always certain that these other parts of the system are still working as expected, because I've got this suite of unit tests that are my safety net.
Okay, now, so this is a source of frustration for me very often. I'll come into an existing code base, maybe somebody else wrote it, or maybe I wrote it a while ago, and somebody says, go modify this method over here and add this new feature.
Yeah.
And I'll do that, and somehow, magically, by touching this part of the system over here, something over here breaks.
Yep.
And it takes me a long time to figure out that the problem is over here, because I'm not even looking over there. I didn't touch over there.
Right.
There's interdependencies. But that's the safety net you're talking about, is by having unit tests I can kind of avoid that.
Exactly. Or, at least minimize the amount of stuff that you do have to go look at, right? Because, the harsh reality is that there's lots of legacy code out there that has no tests or maybe a very few tests. So if you have any tests in your system, then, at least you are cutting away some of the area that you have to dig into when you are troubleshooting.
So the idea is I would make a change over here, and then I would run my tests And if one of those tests fails, it would point to the exact unit that I broke it.
Yeah, exactly.
And that would then I don't have to start digging through and tracing and doing all that detective work. I have a narrow area to start focusing on. Okay, so this sounds great. This sounds really like a huge advantage. I mean, is that a fair statement that this is a big advantage over doing unit testing? Is a big advantage over not doing unit testing?
Absolutely.
So everybody must be doing it, right?
No.
My experience is no.
Yeah.
Why not? In fact, my experience is most people are not doing it.
I think that's absolutely fair.
Why do you think it is?
A number of reasons. So, first off, management. Management doesn't, some management, not all, but some management doesn't understand the value of having somebody, one of their developers, actually writing unit tests. Management may see, well, we have a couple QA resources, they do the testing, why should we have you spending somewhere between 20 to 30 to 40% of your time, or maybe even higher, writing unit tests? Because it does take time to write those tests.
Yeah, take time away from actually writing the actual code.
Right, so the perception, which is a bad one, is that you're losing half of your time that you should be writing features on so that we can deliver. So, there are a number of arguments, and we could go down that trail, but, so management perception, and it's a bad perception. Lack of training. I think throughout our industry, we've got a large number of education issues. You and I hang around at a lot of conferences, a lot of data.net events, we go to user groups, but we're a minority. And within that crowd of folks that even goes to user groups or conferences, when you go to a session, you ask how many people in that room are actually doing unit tests. I think it would be shocking the small number of people that raise their hands. So people haven't been educated about the value of it. Maybe
they're not even aware of it.
They may not be. So some of that awareness gets helped through user groups. Some of the awareness will actually come through Microsoft offering up tooling around that. And I have some harsh opinions and some strong opinions around Microsoft's tooling, but at the end of the day, if they're exposing more people and getting them interested, using that's better than nothing. So lack of awareness, and then fear. A lot of progress in our industry doesn't happen because people are uncomfortable about getting out of their regular routine.
Okay.
Well, I've got to change how I work. I have to go learn new things, and that's some people get a little freaked out with that kind of stuff.
Yeah, that is kind of a bizarre attitude to be in IT and then to be afraid to learn. There's easier ways to make a living if you don't want to learn.
There are, and particularly for folks like you and I who are so engaged with the community, I see those people and it's like, man, not only are you not from Earth, I'm not sure you're from the solar system.
All right, so let's assume that a lot of people watching this show are not doing unit testing. Can you walk us through the process of what a unit test looks like and how I create one?
Sure. So there are a number of tools that you use. To do unit testing, you need to actually have a unit test framework.
Okay.
And so there's several variants of that. Like I mentioned, Microsoft has one that's called MS Test.
Okay, and that one actually ships with Visual Studio.
Yeah, so it doesn't ship with Express, but I think it's Professional and above.
Yes, almost every paid edition of Visual Studio I think it's in. I think so, I'm not sure.
Yeah.
I know it's in most.
Right. So that's part of Studio, certain levels of it. There are open source free versions. There's MBUnit, there's NUnit, there are a couple other test frameworks out there. And what those do is they give you the support infrastructure, the plumbing, to write unit tests. Mm-hmm. And a unit test is, like I mentioned earlier, it's a small chunk of something to do. Mm-hmm. So there are a couple different ways that you can look at tests, but really what you're doing is you're writing a unit test in a separate file or separate assembly, mm-hmm. and it's calling your system under test. And so if I go back to that payroll example, I might have a method over here that takes, that's just compute wages. Mm-hmm. And that compute wages takes in number of hours and rate.
Okay.
and let's say that it's a compute wages for a salary or an hourly worker, right? So if that person works over 40 hours, they should get overtime for anything above 40 hours.
Okay.
All right, so here's my code, that's my production code, and I want to test that. So over here, I write a unit test in my framework, and it's just a simple method, and it's usually decorated with an attribute, the syntax of which is specific to the particular framework that you have.
Yeah, is it fair to say that most of these frameworks have, most of the functionality, most of the frameworks are similar? Right?
Yeah.
There are variations,
Yep.
but they all pretty much work the same way.
Right.
Okay, so
It-
let's describe the generic case.
So you have a test over here, and your test will set up like some input values that you're going to call this with. So in this case, the hours and the rate for that person.
So in programming terms, we're going to initialize some variables and pass those variables in as parameters.
Right.
We call the method.
Yep. So you invoke the method, and then you get the return value. And so that's the actual return value, right?
Okay.
So the whole key thing about unit testing is I get that actual value back, and I compare it to an expected, right? So I set up my conditions, I call that, and then I compare the actual value with what was expected. And the unit test framework, some syntax is different, but it's really just basically assert R equal, and then you say the actual value and the expected. And if those two match, then it'll give you a green light, meaning that test will pass. And if they fail, the test framework will give you a notice that these two didn't match, and it'll point that out right there.
Okay.
And the test framework, the beauty of them is that, so you could write all those comparisons yourself, right? I mean, that's just equality kind of stuff. But for every different return value, you'd need to make your own comparisons. You'd need to put in support for lists and collections and yada, yada, yada.
Okay.
The test frameworks do all of that for you, plus they give you a runner to handle all of that.
So you can run a bunch of tests all at once, or one after another. It'll tell you 19 of these succeeded and one of them failed.
Exactly.
And which one failed.
Yep.
Okay.
Yep.
Well, that's very helpful. So if I have a method, let's say your compute rate method, and I write a test that passes in 40 hours at $30 an hour, and it returns, what's that, $1,200? I don't know. The math is wrong. And I assert that those numbers are equal, that the value returned is in fact $1,200. Is that enough? Write a test, have a method, write a test, check that it works. Is it enough to write that one method?
That one test?
Or that one test, I mean? Yeah.
So here you get into kind of the testing theory. So if we stay with that example,
Yeah.
then in testing, not just unit testing, but testing overall, there's the idea or the notion of boundary testing. So the example I gave was that for a hourly worker, if you are doing overtime, then you should get back overtime rates above 40 hours, right? So you have a boundary there. If it's below 40, then you should get standard, rate times hours.
Yep.
But if you're above 40, then you should get, for that amount of time, time and a half.
So I should test for that.
You should.
My
because
one
you
test
gotta-
was not sufficient. I didn't test the overtime.
No.
So now I need at least two tests.
Right.
I need one with 39 hours, maybe one with 40 hours, and definitely one with 41 hours to see if the overtime's working.
Exactly, and that's the notion of boundary testing. So you need test cases on either side of that. But what happens if somebody passes you a negative value?
Another boundary, 0 is the boundary.
Right, so you
Yeah.
need to make sure that you happen that, because, nobody's ever called a method with invalid.
Yeah, so it
arguments, right?
doesn't really make sense. Well, I should say, we can't physically work negative hours, but you have to decide whether this method should accept negative hours.
Right.
Should it throw an exception? Should it return some special value, or what?
Yep.
Or should it return a negative number?
Exactly. And so that's the whole point of, whatever the logic is you're writing,
Okay.
you need to understand those boundaries, you need to test for invalid cases. Another cool thing about all of the unit test frameworks in general is that you can specifically test for exceptions. So you write your unit test, but then one of the attributes that you mark that with might be expected exception. So if you put in negative hours or negative rate, you could have your method throw an exception with invalid argument, right?
You would test for make sure that
Exactly.
it's thrown properly. Okay.
Yep. So all of those error conditions you need to be testing for to make sure that your method is working as expected. And so here we kind of get back to that notion of a suite of tests.
Okay.
You're checking that that unit of code is working as you expected and is properly handling the regular cases and then also the border cases and then also invalid cases.
Okay. So,
So-
my one little simple method, computing rates, it might have half a dozen tests to test for
Probably
code
should.
numbers,
Probably
a
should.
happy path, overtime, huge number, extremely large numbers. Somebody tries to work as many more hours than a human being expected to have in a lifetime. That might be a
Sure, you may have a business rule there that defines for any work period you can't work more than X hours, and you
Right.
need to ensure that
that's enforced.
that's enforced.
Yeah. Okay. So that sounds. Each test in itself sounds very simple. It's complicated a little bit by the fact that you have to think about these edge cases and think about the border conditions and so on. The tools. Which tools? Now you use the. Do you use MS Test?
I have in the past.
Okay.
Yep.
You like it?
So I've got some strong opinions about it, about a number of problems it has.
Okay.
But at the end of the day, if it's a choice between using MS Test or writing no tests at all, use MS Test.
I'm with you on that.
It's
I've
there.
heard that argument before.
Yeah. So, and moreover, you can probably get your job done in 80% of the cases using MS Test.
So do you have a favorite framework?
I do. I've been a big fanboy of MBUnit for quite some time. And I actually don't do a lot of specific unit test writing these days, but I have I've used MBUnit extensively, I've used MS Test extensively. For the way that I like to do things, MBUnit has a lot less friction. And it
What's
gives
the advantage of that?
I don't have to set up a specific environment. There are less configuration messes as compared to MS Test. I can very easily take all of my tests and drop them on a production server as long as things aren't destructive, right?
Right.
So there's so much friction around testing already. You need to look for tools which let you get the job done with a minimum of friction in your testing, so that you can focus on delivering good stuff. And for me, again, MS Test is better than nothing, but I prefer frameworks which are more mature, they've been around longer, and they get released more often.
Yeah.
MS Test gets released once every
Like 3 years.
3 years.
Visual Studio gets released.
right.
Some people say that we should write our unit tests before we even write our code. Do you agree with that?
I do, and I'm very passionate about that. And this isn't specifically from the notion of testing. It's that it drives design and it enforces you to be very simple about the design and how you implement your code. I'm a big passion of lean. I'm a big passion of keeping very tight things that you keep simple. And if you do test first or test driven development or even behavior driven development.
So just real quickly, test-driven development is the idea that you write your tests before you write your code.
Yes, so you have behavior that you need to specify
Okay.
in whatever code you're writing.
And is that synonymous with behavior development? What
BDD is, no, they're not the same. BDD is another step, and there's a lot of difference around grammar and interactions.
Okay.
Okay,
I don't want to sidetrack you. I just
No.
threw out a couple terms there. I just want to make you.
Well, those are
define
important
those
because, I mean, part of the confusion, part of the fear of people not writing tests is they don't understand all of this stuff, right? So getting something clear about that's important.
Okay.
So TDD and BDD aren't the same. I'm a big fan of using those methodologies because I think it drives a simpler system. I think it drives a higher quality system, but If you aren't going to do those, and if you're scared of doing them or you can't or whatever, do unit testing. I mean, so it's like the MS test thing, right? MS test is better than no tests. A better answer, in my view, is to use one of the other frameworks. And it's the same thing. Test-driven development, or BDD, is the best way to go about things. But if you can't do those, do unit testing, because it's better than nothing.
Agreed. I totally agree with that. This is the perfect is the enemy of good thing. Just because you're not doing everything exactly according to the book,
Right.
don't let that stop you from taking that first step.
Dear Lord, no. And, moreover, some people start to, particularly reading about BDD, because there's just a lot of funky stuff out and about that. It can be very intimidating. So just go write some tests and get familiar with how testing works, and get your feet in the water, start to see some of the payback and some of the advantages, and start to understand how all those parts work, because you can get an understanding and you can get some education, and then you can actually use your brain and some critical thought about deciding how do we want to use these other methodologies, how do we want to use these other tools, and you're actually going to be more informed and better educated.
Because you have some context around the tools that you have used.
It
what
is.
the limitations of those are.
Right.
Yeah, that's a great call. I actually don't write my unit tests first, but I do write them shortly after. I tend to write them in conjunction. So I'll start writing my method, and then probably even before I finish debugging my method, and if I get it 90% of the way there, then I'll write a unit test, and I'll sort of write them in conjunction with one another. So it's not, the way I'm doing it is not technically test-driven development, but it's close to it, I think.
So there's some dogmatic folks that would take issue with that.
Sure.
But again, some testing is better than no testing. For me, so much of it is that starting with that test first and getting into the cadence, because the TDD actually has a very interesting cadence, red-green refactor. And you may or may not have heard this.
Sure.
So
define it for me.
The notion is that I write a unit test that will first fail, and it's nothing more than how I need my system to behave. So if we keep going back to this example of the payroll thing, without ever having written any code on the system under test, I'll write something that says, all right, when I invoke compute wages and I say $30 an hour, 40 hours, I should get back $1,200.
$1,200,
Yeah.
It's in my head.
Yeah. Rural California education, my math sucks. So I do that first, and then I have to stub out the method, right, because it's got to compile. But I don't actually put any behavior over there. And I run my test, and it fails. And then depending on the UI that you have, it'll be like a red stoplight. This comes kind of from the MUnit, JUnit world.
So there's the red in your red.
There's the red. You wrote your test, you wrote your spec on how things should behave, but the system doesn't pass. So now I go make the system pass. And there are a number of things with, using the simplest thing to make that pass, right? So I could actually even hardwire in 1,200 return value. This seems silly, but time and time again when I've done that, I've found that I actually had something wrong in my unit test. So hardwiring in your expected return value is this interesting step of validating
that your test is
that your test works right.
Interesting. So you're unit testing your unit test, basically.
Well, it is, and it seems like this kind of specious, stupid waste of time, but a lot of TDD is kind of about getting into a groove. Right?
Yeah, it's very iterative.
It is, and so many times in coding we talk about getting in the zone, right? When distractions, you just cut everything out and you can just get focused. And this cadence helps you get into that zone and stay in the zone. So, there's my first green, and then the refactor part is, 1,200 is stupid. I can't just hardwire that in.
The next test won't work.
The next test won't work. So I might write another test, and that fails because I hardwired it.
Yeah.
But now I start to build things out, and this is part of that refactoring part.
Okay.
But it also ties back to that whole safety net of building up a suite of tests.
Got it. Okay. You know what I started doing just recently? I've been writing unit tests for years now. Is naming my tests with much longer, more descriptive names. I just bought into that a few months ago, and It helps. It helps because it's, first of all, I can see what I'm trying to do, and it serves as documentation
It does.
for what my code is supposed to be doing. So now my unit tests are doing double duty there. Not only testing the code, but sometimes I'm at a customer site and says, show me what you have, and I have no UI.
Right.
What am I going to do, show them my methods?
Right.
The customer's not going to understand that. I show them the unit tests. And
That's
I
an
say,
awesome
pass
thing.
this in, and it has this, I've got a naming convention, the method name of testing, the word test, inputs, the word
Yep.
should, and then the expected outputs. So these are really long names.
Yep.
But they're very descriptive.
It's very descriptive, and so that is actually kind of moving toward that whole BDD thing, because much of BDD is around a clear grammar that specifies, a lot of those expected behaviors of the system. So even if you're not doing TDD or BDD, it's like writing your code. You use good naming conventions for your code,
Yep.
use the same for those tests, and then there are a number of tools that will actually build you reports from your test suite. And so now, I can build up a little HTML file that shows all of the tests that are running, and like you say, you take some time to name them well, and you do.
All
You've
that
got
report just becomes self-documenting. So,
It does.
Look, this method, I passed in this, it should have returned that, and it failed.
Mhm.
Well, I've got an idea right away
Yeah.
what the problem might be.
Yep.
Yeah. I haven't gone taking that step. That's baby steps for me. I'm getting there.
It's working for you at the moment,
And
right?
I'm buying into what you're saying is that something is better than nothing.
Yeah.
I'm moving in the right direction
And moving.
and moving.
Moving, that's the important part. If you do, obviously I'm a little passionate about testing, but
That's good. We're all about passionate.
get started with something, and then don't just sit there.
No.
Do not just, I've reached this top of the hill, I'm going to plant a flag, and I'm going to stay here for the next 6 years.
Oh my gosh, they keep moving the hill on me.
Yeah, they keep moving the hill. Well, if you don't like change, you'll like obsolescence less. I stole a line from General Shinseki, but anyway, that notion of learn this part and then take the next step, whatever it is, take a next step to evolve how you test and how you build your tests and why you're building them.
Okay, and just real quickly, can you describe, we were talking earlier for something that I hadn't really considered before, using, if you're doing unit tests, a lot of times there's some of the same code has to be used multiple times in different unit tests.
Yep.
And there's ways of abstracting that out. Talk about that. That was,
Sure, so approach your tests the same way you would your code. And so, there's the whole notion of dry, do not repeat yourself. So you
What was
want dry, don't repeat yourself. Man, you hooked me. More coffee. We try to keep those good design principles in the systems we're building because it helps with maintainability and it helps with all those other things. Test code's the same thing. Test code is actually production code, right? So all of that care that you spend over here in production, you should also be doing with your test code. So when you start to find duplicated things, then look to the test frameworks because all of the test frameworks support setup and teardown methods.
right? And I've used those.
And so,
I'm sorry, define those, what those are.
so there are a couple different levels for setup and teardown. So setup, obviously you're creating preconditions for tests, and teardown will clean those up, right? So you can have setup and teardown for each individual test that before test runs, so I've got 5 tests, and each time I need to run setup or teardown for that specific test. But there's also for a test fixture or a class, right? Because you have a class and it has, say, 10 or 15 tests in it.
Okay.
I might need to do something before this group
Right.
of tests run. I can do one setup and one teardown for that entire class or that test fixture.
Yeah, and that makes sense because when I write tests, typically I'll have one test class per actual class. There's a one-to-one issue. And my actual class tend to be all focused around one, the single responsibility. So
Yep.
I just have a class that essentially does variations on a theme on a single thing. So I'm
Mhm.
testing. So now my test class is really testing one object, maybe just customer functionality, or maybe
Mhm.
just customer pay functionality or something like that.
Right. But then, so taking that another step further is, you can do the setup and tear down either per test or per fixture, but sometimes, particularly like say with data setup, it doesn't make sense to do all that because you may need that in several different test classes. So start looking at pushing that functionality off to factories. I mean, we use factories all the time in the software that we build, right?
Okay, yeah.
So why not use that same idea for your tests? You've got common stuff that you need to set up, pushed off to a factory method in a factory class somewhere. You know, I need to new up a new user for my testing, and I've got to do that at X number of different spots in the system. A factory's awesome for that.
I see, okay. I haven't gone to that level. You even mentioned using inheritance too.
Sure, and it's kind of the same thing. We use base classes all the time for systems that we build. Functionality that's common across a couple things. So these days I actually don't write a whole lot of unit tests. I don't write any unit tests. I actually write a lot of tests with Selenium, which is a web UI test framework. And a unit test framework drives my Selenium tests, but it's subtly different. But the point being that with Selenium, I need to instantiate a browser instance. And it's the same set of code that does that for every test class that I'm writing.
Okay, so you abstracted that
So
code out somewhere else.
Yeah, I abstract that out to a base class. So every time I go to write a new test fixture to test, one set of functionality over in the system, I inherit from the base
And
class.
you don't have to worry about the setup code. It's already
Exactly.
there. Okay.
Exactly.
All right, that's really a new concept. I mean, I use inheritance in my code, but I never really thought about using it in my unit tests as well. You're causing me to think, Jim.
Thinking's awful, isn't it? Just stop that. No thinking. No improvement.
That's awesome.
That was a game changer for me, and I absolutely cannot take credit for that. Roy Osherove has an awesome book called The Art of Unit Testing. And so I've used factories and I've used a lot of other things in the past, but Roy his book really made me kind of relook at how I'm approaching things, specifically with that whole notion of inheritance. It's like, oh man, I've been doing this a number of years and duh.
Yeah, that's what I feel right now. It's inheritance, abstraction. This makes sense.
Yeah.
Can't believe I didn't think of that.
Well, that's the whole point. Yeah, we don't think of everything ourselves.
Right.
You have to keep reading and talking with folks, and that's how you learn. That's how you keep evolving your testing.
Is there anything else you can tell us about unit testing? What we haven't covered?
One thing that we talked about why some folks don't unit test. There may be a good, X percentage of people who actually got into unit testing and found it so painful that they stopped. So there's the notion of brittleness in your code, right? Things that as you start changing other parts of your system, this component just starts falling apart. That mimics in test code as well. If you aren't thinking about how you write your tests, be the integration or unit tests or whatever, you can start ending up with so many dependencies that you're spending an inordinate amount of time maintaining those tests because the tests are brittle and they get painful. And so it's a frustration level. So the good design principles that we try to shoot for in our code, coupling, don't repeat yourself, yada yada, all of those things, again, think of your test code the same way so that when you're starting to hardwire in dependencies or other things,
right?
Think for a moment, use your brain. What's this going to cost me when the system changes?
Yep.
And so that's kind of that thing that as you're running into those things, well, wait a minute, so I've done the same thing in a number of places. I need to push that out either to a base class or I need to push it off to a factory because be frank, be honest, unit testing costs you time.
Yep.
And unit tests you have to maintain as well. So if you get things brittle and all of that, then it causes pain. And pain's bad, and it'll build frustration to the point where people would just say, bag it.
Sure. Yeah, I just talked to Gary Short recently. He had a name for this. He called it technical debt.
Mhm.
So building brittle
Yep.
unit tests with lots of dependencies, it cause you to do a lot of funky setup, and that
Mhm.
setup might change over time, so
Yeah.
you have to go back and change it. It's kind of a shortcut we're taking now to get the
Mhm.
job done, and that maintenance later on is debt that we're paying plus interest
Yeah.
to maintain that stuff.
Yep.
And so an investment now can reduce that technical debt. So I think this ties in really well with what he was saying.
Technical debt, again, it's not just the system we're writing, it's on the testing side as well.
Yep, absolutely. Where can people find out more about Jim Holmes?
About me, you can look up my blog at frazzledad.com. You can follow me on Twitter at Jim Holmes. And I make no claim to or guarantee to provide actual useful content anywhere.
You've covered a lot today. I really appreciate it. Thanks, Jim.
It's good chatting with you.
Really informative talk.
Thanks.